Okay lads, right, so the last day we looked at compound interest, and I'll just do a quick recap of compound interest first. So our formula's up on the left hand side there, as you can see, and we're going to start off with Georgia's going to invest 3,000 in a savings account for 3 years at 4%. And I'm sure you all remember how to do this one. Okay, so as you can see, we fill in, instead of P, our principal, we're putting in 3,000. And instead of our interest rate, I put it at 0.04. So if you think of it, the last time we were putting it over 100, so 4% would have been 4 over 100. But this time what I'm going to do is I'm going to put it as 0.04. It's the same thing. If you think of 4 over 100 as a decimal is 0.04. And then of course it's to the power of 3 years. So after that then we can just throw it straight into our calculator and we'll get the answer. So once I've thrown that into my calculator, I get my answer there straight away, as you can see there, 3374.59. Okay, so Georgia, you've got €374.59 more than you had. Okay, so lads, they were the ones we done the other day, and everybody was well able to do them. But we're going to move on to different ones now. We're going to move on to when the interest rate changes year on year. So now it's slightly changed, okay? So now look at our next question. Eva invests 4,000 at compound interest of 3% in year 1 and 2% in year 2. So as you can see, the interest rate has changed between year 1 and year 2. Okay, and banks often do this because they want to maybe, customers, when they see the big percentage of 3%, they say, oh yeah, we'll definitely go with them, and they invest it for 1 year, but the second year the interest rate goes down. So it's how banks, I suppose, drum up new business. So what we have to find here is the value of the investment after 2 years, okay? Similar to the last ones, but what we actually do to change it here is we do it year by year. So now I'm going to do it year by year, okay? So we'll put our 5,000, so we'll use the same formula again, of course, and we'll put our 4,000, as you can see there. We're going to put that into the formula, but instead of the usual, so you remember that what we usually had was we had to the power of maybe 2 years, 3 years. In this case, it's only the 1 year. Okay, only the 1 year. So once we put that into our calculator, we get our answer of 4120. So now what we have to do is we have to start year 2. So again, as I said, we're doing it year by year. So into year 2, there we are. We're putting in what we ended year 1 in. So that's what I mean by doing it year by year. So what we ended year 1 with was 4120. So now that goes into our formula with our new percentage rate of 0.02. And we get our answer of 4202.4. So that's the value of Eva's investment after 2 years. Okay, right. Now, of course, if at any time you want to pause these slides, well, do pause them. And then what you can do is you can take down these two as examples, okay? I'm sure you got the first example okay, just in case you want to take down the second example to help you with some of the questions that we have at the end, well, of course, go ahead. So some of you might have noticed something, that this probably isn't too dissimilar to percentages we've been getting before. Not too dissimilar at all. So when usually we are putting it as, well, first of all we put it as 1 plus maybe 2 over 100, and then I got you to change it to 1 plus 0.02, and that's pretty much the same as 1.02. It's no different at all, okay? So if anybody wishes maybe to use that instead, of course they can do this here. It's all the same, okay? So that might come in handy now for our next example we're going to try. So now, our new aim for today is to find a missing value in a compound interest sum. So this is when maybe we're given our final fee, our starting fee, but not our interest rate. Or maybe we're given our interest rate and we're not given what our starting fee was, what our principal was. Okay, so we're going to try maybe 1 or 2 of these, maybe just the one, and if you get it after the one, I'm sure you'll fly along with everything. Just, I suppose, the important thing to remember here is you're always doing the opposite action. So when you do something across an equal sign, as we'll see in a minute, you're doing the opposite action. So now, just remember our formula for compound interest, because we're going to need it here. So, example 1. Connor invests a sum of money at a rate of 4% for 1 year. At the end of the investment, the value of the amount is 9276. Find the sum invested. Okay, right, so in this case, well, as you can see, I spelled value wrong. We have to find the principal. Okay, so we're going to find the principal. And again, if you want to pause maybe and take down this, that's fine. So of course, remember our formula. And as you can see from our formula, we've f is equal to p bracket 1 plus I to the power of t. Alright, so in this case, what we have in 9726, or 9276 even, is our is our final fee. So we need to find our principal. So we're going to do that now. So I filled in everything I have so far. I filled in my final fee, I filled in my time of 1 year, and I filled in my interest rate. So remember, my interest rate is 0.04, and I've condensed that and I've made it 1.04 because it'd be 1 plus 0.04, which of course is 1.04. That's all I've done here. If you want to do it the other way, of course, you're more than welcome to do it that way. So the next thing I need to do is start switching things across the equal sign, because what I'm trying to get here is my principal on its own. So if you think of it, you're sort of rearranging in algebra and you're trying to get p in its own. So at the moment, p is multiplied by 1.04. Now it's to the power of 1, so I don't even have to have that 1 there. Next year we'll be doing when it might be 2 years or 3 years, and when we're doing them, well, there's something little that we have to do then. I'm sure you probably know already, some of you probably get it already. But anyway, we'll move on. So what I've done here is the 1.04, that was multiplying. And remember the opposite action to multiply, I'm going to bring it across the equal sign and it becomes a divide. So it's 9726 divided by 1.04, and that's equal to the principal. As I said already, to the power of 1 just means, well, it's multiplied. It's not multiplied by anything. If it was a power of 2, it'd be something a little bit different, but as I said, we'll get on to them ones next year. So at the moment, it's just simply bringing 1.04 across here and dividing. And that's what's equal to the principal. And now it's just a matter of putting 9276 divided by 1.04 into my calculator. So once I divide this now, as you can see, I get 8919. I think it's 0.23 or something, but don't worry about that for the time being, okay? And that would be my principal. So that's what Connor invested at a rate of 4% for 1 year. All right. Now, I'm just going to show you one more small example. So what if we hadn't got the interest rate? What if we were given the final fee, the principal, but we didn't know the interest rate? And that's the one I'm going to do just on the side here using the same figures. So what if we had something like this here on the right hand side? So again, I'm using the same figures. I know my ending fee, my final fee. I know my principal. Okay, and I've just got my principal from the last one. But what if I didn't know what my rate was? What if I didn't know my rate was 4%? How would I find that? Well, again, you're doing the opposite action. So as you can see here, on the right hand side, 8919 is multiplied by 1 plus the interest rate. So I want to get the 8919 on the far side. So what do? At the moment it's multiplied, I bring it over and I divide. So this is what I have here. 9276 over 8919 is equal to 1 plus I. Again, I've just got rid of the 1 in this case here because we're never dealing with it in second year, more than 1 year. Okay, so we're just going to divide them two next. So I divided both of these here and I got 1.04, and that's equal to 1 plus I. I just got rid of the brackets here because they were serving no purpose anymore. So 1.04 is equal to 1 plus I, and now again I'm doing opposite action. So as you can see here, I want to get my I in its own. Doing a little bit of algebra here, trying to isolate your I. So I'm going to bring my 1 over the other side. And what happens at 1 when it crosses an equal sign? At the moment it's plus. When it crosses opposite, it becomes a minus. So, as you can see what I've done here, I brought the 1 over, it's become a minus. So 1.04 minus 1 is equal to I, which is 0.04 is equal to I, so that's 0.04, which is 4%. Exactly the same as I started off and up here. Okay, so on the next slide I'm going to give you a few questions to do out of the 2 images that I would have uploaded. Alright, so I'd like you to do them, and I'm also going to leave you questions out of your book. So here's the work for today's class. So if you want to try and get this done in the class, it'd be brilliant. And if you've any left over, do them for homework, okay? What we're also going to do then, we're going to start a new topic on Thursday. So this is pretty much then all the likes of compound interest, tax. And as you can see, it's pretty much just like a compound interest, like an added on tax. But that's pretty much all of that finished then. So we'll be going to Pythagoras theorem on Thursday, and we'll do something fun on Friday. Okay.